Okay, one method, that's it. You implement this method to draw what you want. Now it has that argument there, that's a performance optimization. That's basically a rectangle that says, well, please draw yourself, but really I only need the stuff that's in this rectangle in your coordinate system. But if you want to ignore this rectangle and draw all of yourself, that's fine by me. Okay, so it's purely a performance thing. Some views, it'll make sense to look at that rectangle and be really efficient. Like we had an assignment a couple years ago in this class where you're drawing a graph. Well, if you're drawing a graph and you're having to calculate every point, it's kind of nice to only have to calculate the points in some part of the graph instead of drawing the whole thing every time. But if you're drawing a playing card, it's so lightweight to draw it, you can just draw all the parts of it. You don't have to use the rectangle.
If you draw outside of the rectangle, does that stuff show up?
The question is, if you draw outside the rectangle, does that show up? Remember that everything you draw shows up unless you have one of these clipping things I talked about on where you're like your super view is clipping you, or you have a clip rect as part of what you draw. So the answer is that rectangle has nothing to do with clipping. Okay? No matter what that rectangle is, clipping or not, is unaffected. Okay? It's purely performance. I'm giving you a hint of what needs to be redrawn. That's all it is. So really important. Never call DrawRect. If you call DrawRect in a homework assignment in this class, you are going to get dinged because I'm putting it in red, never red, and I'm telling you, don't ever call DrawRect. DrawRect is for the system to call. Okay? If you want your view redrawn, you call the method setNeedsDisplay. And that tells the system this view needs to be redrawn. And then the system will call DrawRect at an appropriate time. Okay? The system knows when it's an appropriate time to call DrawRect, update off-screen buffers, whatever heck it has to do, it's in control of that. Don't ever call DrawRect. It just will not work to call DrawRect, okay? setNeedsDisplay. And you can do setNeedsDisplay in rect, that's giving the little optimization rect, okay? But setNeedsDisplay is how you do that, okay? All right, so how do I implement this DrawRect thing? Okay, I got this DrawRect method, I want to draw something. Well, the answer is you use this library, the Quartz library. It's called Core Graphics. Core Graphics. It has a ton of C functions that all start with CG, Core Graphics. They almost all take a context as the first argument. We'll talk about that. Or you can use this nice class called the UI Bezier path. And UI Bezier path lets you build all these complicated shapes into a big path, and then you can stroke it or fill it on screen. Okay, so let's look into these. To understand these, we need to understand a little bit about how Core Graphics thinks, and it thinks in the following four-step process. You got to have a context to draw in. You got to create paths, triangles, squares, whatever, rounded rects, whatever it might be. Then you set the colors and the fonts you want to use and line widths and all that stuff, and then you stroke or fill the paths that you created. This is the fundamental way Core Graphics goes. Okay, so let's talk about all those things. UI Bezier path, by the way, encapsulates doing all of that. Okay, it takes care of the context for you so that you don't even have to think about that. You create paths by sending messages to a UI Bezier path instance. It lets you set colors and line widths and all that, and then it has methods to stroke and fill. So it encapsulates all that mechanism. So let's talk about the context. Mostly you don't have to worry about context because you're going to use UI Bezier path. I'll show you a way if you're using the CG functions to get the context to draw on screen. But a context means where am I drawing in terms of am I drawing on screen right now? Am I drawing off screen in some bitmap? Am I creating a PDF file out of what I'm drawing? Am I drawing to a printer? The iOS has great printing support, and so you could be drawing to print a page on an AirPrint printer or something like that. So that's the context part of it. For normal drawing, UIKit sets this context up for you before it calls DrawRect. And then once you're in DrawRect, context is ready to go. UI Bezier path knows what it is. And if you want to call the CG functions, you call this method UI graphics get current context. If you call this inside your DrawRect, you'll get a little cookie that you can hand off as the first argument to all these CG Core Graphics functions. Okay? And you're not going to need those CG functions very much, only when UI Bezier path won't do what you want, which is pretty rare. Okay, so this is the magic thing. That context ref is just, it's a void star. You don't know what it is. It's opaque. This thing is new every time your DrawRect is called, so never keep that thing around. It's only good from the start of your DrawRect to the end. Don't keep it in a property or anything that's going to live. Okay, call the UI graphics get current context each time at the start of DrawRect. Okay, so how do we define a path? So let's say we want to do a triangle with UI Bezier path. We alloc init a UI Bezier path like this. We move to wherever our starting point is. So I'm going to move to the top there, 75 across and 10 down. Then I'm going to add a line to that point, going down to over to 160 down to 150. I'll add another line to come back to 10, 150. And then I'm going to close this path by calling close path. That goes back to where we draws a line back to where I started. So I have a nice triangle there. Now I'm kind of misleading you because as I'm making all those calls in UI Bezier path, nothing is actually happening. Okay, the screen is blank. Okay, because all I'm doing here is building that path up in that UI Bezier path. I haven't actually drawn it yet. When I want to actually draw it, I have to set my fill color and stroke color, and you can do that by sending set fill and set stroke to a UI color. Just get a UI color like you did for attributed string or whatever, UI color, same thing. Call set fill or set stroke. You can even just say set, and it'll set the fill and the stroke to be whatever color you send it to. And once you have your color for fill and stroke set, you send a message to the path saying fill and or a message to the path saying stroke. And now it will actually draw. So those last two calls there, fill and stroke, those are the things that cause drawing to happen. Okay? Everything else is just like setup. Make sense? Okay? Now this might all seem like, whoa, triangle, great. I can draw a triangle. Sounds easy. But there's actually a lot that UI Bezier path can do that's really much more sophisticated than that. You can set your line widths and things like that to make your drawing, you know, you can set patterns and all kinds of stuff like that to make it more interesting. And also UI Bezier path has a lot of cool functions like Bezier path with rounded rect corner radius. Okay? And that will give you a path which is a rounded rectangle inside of certain bounds. Okay? And it has a bunch of other ones similar to that so that you can build more complicated things than line 2, line 2, line 2. Okay? I just show you that because it's simple. Right? So that's how you would, for example, create an oval. You can also use UI Bezier path to clip your drawing. This is super important. You will need this for your homework, I think. I suppose there's a way to do the homework without this, but I can't think of a way. Well, I can, but it would be extremely tedious. Rounded rect, for example, could be used to clip your drawing. So if you wanted to draw some kind of pattern, but you wanted it to be inside a rounded rect, you just get a rounded rect, just like earlier in the slide there, and say add clip. And at that point, from that point on, all your drawing will be clipped to be inside that Bezier path. Okay? And there's ways to add more clipping, to turn off your clipping, that kind of thing. So clipping is an important piece of UI Bezier path as well. Okay, let's talk about drawing with transparency in UIView. Okay, UI views by default are opaque. They have a background color. By default, it's white. And so if you put a view on screen and just run, it'll come out as a white rectangle. Okay? So that's not always what you want. So for example, in a playing card, I want it to have rounded rect. And I want those corners to show through. Maybe there's a card behind or something on the playing table that the card is on or something. So I don't want it to be opaque. So you're going to see in our demo, we're going to have to turn this opaqueness off. The way you turn the opaqueness off is you have to set this property opaque in UIView to no. In other words, you have to tell the system this view is not opaque. Even if you set the background color to nil, okay, which means I don't want a background color, it still won't be transparent because of this. This opaque isn't a performance optimization, but it's a hard optimization, meaning it just won't work if you don't set it to the right thing. So if you want your view to be transparent, you have to set opaque to no. You're also going to want to set your background color to nil so that it's not filling with a background color. It is also possible to make your entire view transparent with alpha. Okay? So UIView has a property called alpha. If you set it to 50%, then everything in your view will be 50% see-through, right? 50% transparent, or 20%, or whatever percent you want. That's the entire view, no matter what's going on inside. And of course, you have transparent colors that you could draw with, fill with, stroke with, whatever, to draw transparently that way as well. So there's a lot of ways to draw transparently in your view. What happens if you draw transparently and views overlap? Well, they show through to each other. Okay? And I told you that the order in which you add the subviews matters. Okay? Every view has a property an NS array called subviews. It's the list of views. And the order matters. The lower ones in the array, okay, the ones that like at 0 are in the back, and the ones down at the end are in the front. All right, so the subviews array is from back to front. Okay, and things can overlap and whatever be on top of each other, and they will show through. If you had an opaque one in the middle, it would all of a sudden block all the ones in the back. You see what I mean? So it's as simple as that. Now, having transparent views is not cheap. We talk about performance optimization, and one of the biggest mistakes I think computer science students make is premature optimization. You're in there optimizing stuff that just doesn't matter. This matters. If you have a lot of transparency, it's going to be a performance hit because you're talking about having to composite those views on top of each other with alpha, way more expensive than just blasting the bits in there. Okay, anyone who's taken graphics knows what I'm talking about. So this is something to be a little careful with. If you're going to set that opaque to no, understand there's a performance cost there. Yeah, that's what I'm saying. You can also hide a view entirely. Okay, so it's just like, think of it as alpha of 0, like you can't see anything, but it also won't get any gestures. It's almost like removing it from the view hierarchy, but you're leaving it so it has its space in the subviews list. It gets to keep that, but otherwise it doesn't appear. It doesn't draw, doesn't get events. It's like it's not even there. Why do you want that? Well, because sometimes you just want to temporarily remove a view from the hierarchy and then put it right back in. So you said, or put it back in some short time later. So you say hidden equals yes, it's gone. You say hidden equals no, oh, it reappears, okay? So that's better than setting the transparency, although I think mostly the UI kit probably optimizes alpha equals 0 to be the same as hidden, is my guess, okay? Probably won't have to do that in your homework, is my guess. But you might, depends on what kind of sophisticated UIs you build. I'm not going to go through this slide, but you can imagine that if you're setting up fill colors and clipping and all that stuff in a subroutine, when you come back from the subroutine, all those things might still be set, and that would be bad. Okay? So you want to be able to push and pop your state, basically save the current graphics context and then restore it, and that's what these functions do. CG context save GState and CG context restore GState will save everything, all the fill colors and clipping regions. You go do a bunch of stuff, you know, clip and fill and everything, and then you restore and you're back to where you were. So that if you have your DrawRect and it calls this draw green circle thing, it won't come back to your DrawRect and now everything's drawing in green. Okay? So that's a push and pop basically of the state. All right, drawing text. Okay, it's all great drawing triangles and filling them with colors. What if you want to draw text inside your view? Well, of course, we use UI label to draw the vast majority of text on the screen in UI kit, but you can use NS attributed string to draw any text you want. And it could not be simpler. You create the attributed string with all the attributes you want, no restrictions, exactly like you learned to do in this last homework assignment. And then you just send a message to that attributed string, draw at point, this point. And that will be the upper left corner of a rectangle that includes all of that attributed text. Okay? It could not be any simpler. You can also find out how big that text is going to take, how much space that thing is going to take by sending size to the attributed string, and it'll tell you how big it is. Now, you might be a little disturbed by this and like, whoa, attributed string is not really a UI kit thing. All the properties inside usually are, but it itself is not. And that's true. UI kit actually adds these methods, draw at point and size, and there's a few other ones. It adds them, even though it's in a completely different framework, using a mechanism in Objective-C where you can add methods to classes without subclassing them. Okay? It's called categories. It's talk about Wild West. That's why I don't show you until about halfway through, because it can be abused, this mechanism. But that's how this is working, for those of you who are wondering. Drawing images is almost the same, but instead of an NS attributed string, you get a UI image. So you know how to get one out of the image asset library with image name. There are other ways you can create them from files. You can even draw into an off-screen bitmap to create a UI image. Once you have a UI image in your hand, you just send it draw at point, which will draw that image with its upper left-hand corner at the point you specify, or draw in rect,